All right, Advanced Math 8, here we go. We've got lesson 6.2.2, solving systems of equations using substitution. Now, in the last lesson, we were solving using the equal values method. And on 6-55, we want to use the equal values method. And the reason why we're going to use it is we're going to show you why it's a bad idea. All right, so we're going to use equal values. I already have y isolated, so I want to isolate y over here. So I would probably subtract 3x from both sides. Again, we're going to do this. You're going to see, oh, that's ugly. And then say, okay, there's got to be a better way to do this. So not all problems are probably good problems to be doing the equal values method. So we got negative 3x minus 13. And then I'm going to divide everything by 5. So divide this by 5, this by 5, and this by 5. So I get the value of y is equal to negative 3/5 of x minus 13/5. So we can see here that we've got these kind of ugly fractions, and it's really unnecessary to have these fractions in here. But using the equal values, what we would do at this point is we'd say, okay, y is equal to this, and y is also equal to that. So let's let this and that equal to each other. So I get negative x minus 7 is equal to negative 3/5 of x minus 13/5. Let's get rid of those fifths. Let's multiply both sides by 5. And let's make this a little bit nicer. So if I multiply everything by 5 using my multiplication property of equality, I get negative 5x, oops, wrong color, negative 5x minus 35 equals negative 3x minus 13. Okay, so at this point, I would probably, I don't know, add 5x to both sides. And that would give me negative 35 is equal to 2x minus 13. And then I would probably add 13 to both sides. And so then I'd get, what's that, negative 22? Yeah, I think so. Equals 2x. So x would be equal to negative 11. Now that I know that x is negative 11, let's plug it into this equation here. So if I plug it into that equation over there, I've got y equals negative 11 plus 7, or minus 7, sorry. So this is y equals 11 minus 7. So it looks like y is going to be equal to 4. So I've got an answer, and my answer is x is negative 11 and y is 4. Okay, how do we know if we got it right? By plugging it into this other equation here. So let's go ahead and do that. 5 instead of y, we're going to plug in 4. Plus 3x, instead of x, we're going to plug in negative 11. And then minus equals negative 13. So I get 20 minus 33 equals negative 13, and it does equal that. Negative 13 equals negative 13. Cha-ching! I know that I did it right now. So my answer is negative 11 for x and 4 for y. All right, so you see that there was a lot of fractions that happened when I tried to do the equal values. Generally, you probably only want to do the equal values method when you already have variables isolated by themselves. Like both the variables are like y equals, and then, or both equations have y equals or x equals or something like that. That's when you really want to use the equal values method. Substitution is actually really similar to the equal values method. In substitution, here's what we would have done instead. So we would have started with y equals negative x minus 7, and then 5y plus 3x equals negative 13. In substitution, I see that y is equal to negative x minus 7. So in this equation over here, instead of writing the letter y down, I know that y is equal to this. So I can substitute in, instead of the y, negative x minus 7. So that would give me 5. Instead of y, I plug in negative x minus 7, because that's what y is equal to. And then plus 3x equals negative 13. And the reason why we would do it like this is because now we're not going to get into those fractions that we had to mess with. So this gives me negative 5x minus 35 plus 3x equals negative 13. Combine our like terms, we get negative 2x minus 35 equals negative 13. Add 35 to both sides, we get negative 2x is equal to 22. Divide by negative 2, and we get x is equal to negative 11, which is exactly what I got right here. And then we can plug in right over here. So I can do y equals negative 11 minus 7. So this part's exactly the same. And then we get y equals 11 plus or minus 7, and y is equal to 4. So either way we do it, we still get the same exact answer of negative 11 comma 4. I think there's a little bit less work to do with this one. There's fewer places where you can make a mistake. Because over here you had to isolate the y first. Well, you can make a mistake there. And then you had to set them equal to each other, and they're fractions, so you could have made a mistake there. Then there's all the solving over here, you could have made a mistake there. There's not a lot of places you're going to make a mistake on substitution, except a lot of people forget not to distribute to both of the numbers, or the negatives throw them off, but there's fewer places, comparing all of this work to this work right here, there's fewer places to make a mistake in the substitution method. But like I said, if both of these were y equals something and then this one was y equals something, yeah, equal values method, best way to do it. All right, here we go, next one. Bharat and Ingrid leave their building at the same time on their bikes and travel in opposite directions. Bharat's speed is 12 kilometers per hour. Ingrid's speed is 14 kilometers per hour. How long will it take until they are 78 kilometers apart? All right, so they're starting at the same spot. So here they are at the same spot, and then they go in opposite directions. Okay, so one of them is going, the speed is 12 kilometers per hour. And then the other person is going to go 14 kilometers. All right, how long will it take until they are 78 kilometers apart? So this entire distance should be 78. So from here to here, that's 78. Now they're going at different speeds, so they're not going to go in equal distance. So this is not going to be equal to that because it's different speeds. So we want to know how long, that's time. So we're going to let t equal how long, or the time. And that's going to be time in hours, because we're going to do kilometers per hour. So we're letting t equal the time in kilometers per hour. Now we need to define, the first thing we're going to do is we're going to solve with two equations. Okay, so here's the problem. I know that Bharat, I can do his distance. He's going to do 12 kilometers per hour. So I'm going to let B equals Bharat's distance. So here's what I can write. I know that Bharat's distance, B, will be equal to, his speed is 12 kilometers per hour, so it's distance equals rate times time, so his rate is 12, times the time. So that's pretty straightforward. We're going to do his distance equals 12t. Now the harder part is, what do we do about Ingrid's distance? Because I don't want a third variable. You usually don't want third variables. So to show her distance, we know one side of the equation should be 14 times t. We know the total distance is 78. So Ingrid's distance would be 78 minus whatever Bharat went. So her distance would be 78 minus b, because it's the whole distance of 78 less whatever Bharat traveled. So there's our two equations. We already have a variable that is isolated. So what we can say here is that 12t can substitute for b over here, because b is equal to 12t. So instead of b right here, I can plug in 12t. So that would give me 78 minus 12t is equal to 14t. I'm going to add 12t to both sides. And this gives me that 78 is equal to 26t. I think that goes in there evenly. It definitely does. That's 3. So dividing by 26 on both sides, I get that t is equal to 3. So it took them 3 hours to get the 78 kilometers apart. Now, if I wanted to find out how far did Bharat travel, Bharat is 12 times t, 12 times 3. So he went a total of 36 kilometers. And in order to find Ingrid, all we would have to do is say, okay, Ingrid is 78 minus Bharat, which was 36. So 78 minus 36 looks like, what, 42? Yeah. All right, so how long will it take until they are that long apart? We just found out it will take 3 hours. Now, personally, on this problem, I really like to use 3 equations on this, and here's how I would do it. I know that Bharat's distance, and I'll call him D1. So I'm going to let D1, distance 1 equal Bharat's distance. And then I'm going to let D2, or D sub 2, be Ingrid's distance. All right, and then I'm going to let T equal the time. And of course, this is time in minutes. And these are in kilometers. And this is going to be time in hours? Yeah, hours. So Bharat's distance is going to be equal to 12t. Ingrid's distance, d sub 2, is going to be 14t. Now what I know is that the two distances, so this one right here would be d1, this one right here would be d2. The two distances, if you add them together, they should add up to 78. So the distance that Bharat bicycled plus the distance that Ingrid bicycled is equal to a total distance of 78. And now what you can do is substitute for D1 and substitute for D2. So you end up with 12t, because that's D1, plus 14t, because that's D2, equals 78. So you get 26t equals 78, so t is equal to 3. Same problem, just 2 different ways to look at it. All right, we're almost there. When May solved the system of equations below, she got the solution x equals 1 and y equals 6. Without solving the system, can you tell if the solution is correct? So she has x is 1, y is 6. Well, to tell if it's right, we just have to plug in 1 and 6. So let's plug it in here. 4 times 1 plus 3 times 6. Does it equal 22? Let's see, 4 plus 18. I get 22 equals 22. Okay, so far it's right. But it has to work for both of them to be a solution to the system. So I have to plug it into this one too. So x is 1 minus 2, and then y is 6. So if I plug it in, I get 1 minus 12 equals 0. And no, that is not true. I get negative 11 equals 0. So no. So our answer is the solution is not correct because it's not a solution that works for both of the equations. And systems, it has to work for both of them. So no. If it fails one of them, it fails both of them. It's not enough just to work with one of the equations. It has to work for both of them. Remember, these are where two lines are crossing. So we're looking for that one point where they both cross. So we're looking for the place where it's a solution for both of them. All right, almost done. 2 more problems. You have decided to give your best friend a bag of red and green marbles for his birthday. That's very sweet. Your friend likes green marbles better than red ones. So the bag has twice as many green marbles as red. Well, if he likes green marbles, why didn't you just give him green marbles? That'd be too easy for the problem, I guess. Okay, the bag contains 84 marbles. How many green marbles are there? Okay, so we need 2 equations, 2 variables. Let's start off with the obvious. We're going to let G equal the number of green marbles. Do I have a red pen? Oh, I do. Yes, I do. And we're going to let R equal the number of red marbles. See what I did there? Green and red. All right, so I need to find 2 equations that I can make. Okay, let's read through until we'll see if we can find one. Okay, blah, blah, blah. That's just fluff. Your friend likes green marbles better than red ones. That's fluff too. The bag has twice as many green as red. So there's twice as many green. So there's more green than red. So one way that we can write that is that green equals 2 times the red, because there's twice as many of these than there are these. So like, let's say that I had 5 red. That would mean there's 10 green because I have twice as many. If I had 20 red, that'd mean there'd be 40 green. So there's my first equation. Green equals 2 times the red because there's twice as many green. Our second equation is from this last part. The bag contains 84 marbles. Well, what's in the bag? Well, marbles. What kind of marbles? Red and green ones. So I can write the equation. The green marbles plus the red marbles equals 84. And now I can do substitution because I have a variable isolated here. So I can plug in for G right there. So that would give me, instead of G, I'm going to substitute and plug in 2R plus 1R equals 84. So I get 3R equals 84. And then R is equal to 8. I think so. 84 divided by 3, 28. All right. All right. The bag contains blah, blah, blah. How many green ones are there? We did not solve the answer. We found out how many red ones there are. So in order to find out how many green ones there are, I'm going to have to use this equation here. Green equals 2 times R. R is 28. So green is going to be 56. So there are 56 green marbles. Now, how do we know if we're right or not? Well, I know it works for this one because 28, if I multiply 2 times 28, I get 56. We double check by plugging it into this one. 28 for red, 56 for green. Is 56 plus 28 84? Yes, it is. So I know that my answer is right because it works for both equations. All right, last one. Carter walked for a while at 3 miles per hour. Miles per hour, okay. And then continued on his journey on a bus traveling 15 miles per hour. Okay. His time on the bus was twice as long as his time walking. How long did he ride on the bus if the total distance covered was 66 miles? So a couple different ways that you can do this. You've got our little friend Carter here. He starts at one spot and then goes to a different spot. And we know that the total distance is 66 miles. Now, there are two sections to this. From here to here, he's going to walk. And then from here to here, he's going to get on a big old bus. All right, so he gets on the bus there. Yay. So part of it, this part, stupid lights. He's going 3 miles per hour. And then this part of the journey, he's going 15 miles per hour. So he's got two different sections of his journey. Okay, so let's make 3 equations because that's how I like to do these types of problems. So let's make distance 1 equal the miles that he walked. Let's make distance 2, I was supposed to say let equal the miles he rode on a bus. Okay, and then time, we're going to need that. So we're going to let t equal time, and it's per hour. So this is going to be time in hours. All right, so let's write an equation for the distance that he walked. So the distance that he walked is going to be d1 equals 3 miles per hour, so rate times the time. Let's write an equation for the distance on the bus. Distance on the bus is rate times time, so 15 times the amount of time. And then what do we know about the two distances? Well, his walking plus his bus riding, got to write bus, is going to be a total of 66 miles. So that means I can also write the equation d sub 1 plus d sub 2 equals 66 miles. So now I know the distance that he walked plus the distance that he rode on a bus equals 66. And now I can substitute. So I can take, instead of d sub 1, I can plug in d1. Instead of d sub 2, I can plug in d2. Let's do that. I get the equation 3t plus 15t equals 66. So this gives me 18t equals 66. And then I'm going to divide by 2, or divide by 18. So I'm going to do 66 divided by 18. 3.6 repeating. All right. What'd I do wrong? I don't think I did anything wrong. All right, so we get 3.6 repeating for that one. Oh, all right, I had to pause it because I knew that I did something wrong. I left out this part. Twice as long. So let's make, my bad. Let's make t equal to the time that he walked. Okay, so that was a little bit of a mistake there. So let t equal the time that he walked. So over here when I made d2, this should be 2 times t. Because he went twice as long on the bus. So there's my mistake there, which not going to really change it. Well, it's going to change it, but this is going to be 30. And then I'm going to get 33. This is why you should read everything. So I'm going to divide by 33. Now it makes more sense. And we get t is equal to 2. So what is t? T is the time that he walked. So we know the time he walked is 2 hours. And then how long did he ride the bus? Well, the bus is t times 2, so it's going to be 4 hours for the bus. So we're going to say that time on the bus is 4 hours. All right, good times, people. Here we go. That's all I got. Math hard, and make sure to read the entire problem and not miss stuff like that. All right, you have a good day. I'm going to go home. Bye-bye.